Mars, the red planet, a world that, from a distance, seems still and lifeless, its reddish soil and arid deserts painting a picture of desolation. But if we look closer, beneath the surface, beneath the dust, there are whispers of another time. A time when the Martian landscape was lush, with rivers that flowed into vast oceans and skies that held the warmth necessary for liquid water. For centuries, scientists and dreamers alike have wondered, could Mars have once supported life? Could its oceans have been home to the building blocks of life, perhaps even life itself? As we peer into the distant past of this enigmatic world, we begin to realize that Mars's history is not one of solitude, but of change, profound, catastrophic change that shaped it into the cold and barren world we see today. Picture a time, billions of years ago, when Mars was not the desolate planet we see today. Instead, imagine a world bathed in the light of a young sun, with a thick atmosphere, one that could sustain liquid water. The surface was not just a patchwork of rocky plains, but a dynamic, water-covered world. Oceans once covered large portions of the northern hemisphere, while rivers carved intricate paths through the land, pouring into vast, saline seas. Large volcanic eruptions added to the drama, pumping steam and gases into the air, creating an atmosphere thick enough to trap heat and keep the planet warm enough for water to remain liquid. A young, vibrant Mars, alive with the forces that shape planets, capable of sustaining not only water but the very conditions necessary for life to emerge. These ancient Martian oceans may have been different from the ones on Earth, but they were oceans nonetheless, bodies of water that could have been teeming with microbial life, providing a rich environment for chemical reactions. In fact, many scientists believe that the origin of life on Earth was shaped by conditions very much like those once found on Mars. Could Mars, too, have given birth to life in these early oceans? We may never know for sure, but the evidence we've uncovered thus far suggests that Mars was not always the inhospitable world we know today. It was once a planet capable of supporting life, at least for a time. As we examine Mars from orbit, the evidence of these ancient oceans becomes apparent. The northern plains of Mars, stretching across vast areas, are thought to have once been a shallow sea, its waters covering much of the low-lying regions. The scars left behind in the landscape, ancient shorelines, river deltas, and valleys carved by water, are the remnants of a time when liquid water flowed freely across the planet. The Valles Marineris, the Grand Canyon of Mars, is a stunning reminder of the immense forces that shaped the planet. Though it is often thought to have been formed primarily by tectonic activity, we now know that water, too, played a key role in carving its deep, winding channels, further evidence of Mars's wetter past. Valles Marineris wasn't always a canyon of dust and rock. In the distant past, it could have been a river valley, where water once flowed through the landscape, creating deep ruts and winding paths that remain frozen in time. The shorelines that wind through Mars's surface may no longer touch water, but they speak of a planet that could have been covered in liquid oceans. These features, though ancient and eroded, are among the strongest evidence we have that Mars was once a planet very much like Earth. A planet with an atmosphere thick enough to support oceans, rivers, and perhaps even the building blocks for life itself. But what happened to Mars's oceans? How did a world with such promise transform into the cold, barren landscape we know today? The answer lies in the planet's gradual loss of its atmosphere. In its early history, Mars had a thicker atmosphere, a warm, carbon dioxide-rich blanket that trapped heat and kept the planet's surface habitable. But as the planet's magnetic field weakened, solar winds began to strip away the atmosphere. Without the protection of a magnetic shield, Mars's atmosphere gradually thinned and temperatures plummeted. Water, which once flowed freely, began to evaporate and freeze, its oceans receding into the planet's history, leaving only faint traces behind. Over billions of years, Mars became the dry, frozen world we see today. The once thick atmosphere that protected the planet's water was gradually stripped away, leaving behind a thin, fragile layer of gases. As a result, Mars lost its warmth and its oceans, frozen out of existence. And while some water may still exist as ice beneath the surface, Mars has become a shadow of the planet it once was. A world that might have been capable of sustaining life, yet is now a silent witness to the forces that shaped it. Though Mars has lost much of its water, scientists continue to search for signs that life may have once thrived in its ancient oceans. With each rover mission, we uncover more evidence that Mars was once hospitable to life. The Curiosity rover, for example, found ancient rock formations that suggest the planet's surface was once warm and wet. These rocks, smooth, layered, and rich in minerals that form in water, are the fingerprints of a planet that once harbored lakes and rivers. And it's not just minerals that intrigue us. The chemical building blocks of life, organic molecules, have also been found in Mars's soil. These molecules, though simple, are the foundation of life as we know it. While they don't prove that life ever existed on Mars, they raise the tantalizing possibility that, in Mars's ancient past, life may have once called this planet home. The mystery deepens with every discovery. If Mars had oceans, if it had the right conditions, could life have taken root here? And if it did, where did it go? The mysteries of Mars's oceans are far from solved. As we dig deeper into the Martian surface, we are confronted with more questions than answers. Did life ever emerge on Mars, only to be destroyed by the planet's gradual transformation? Could there still be water hidden beneath the surface, waiting to be uncovered? And might there be microbial life in those ancient, buried waters, locked away in the planet's frozen history? The evidence we have suggests that Mars was once a world of possibilities, a planet capable of sustaining life. Yet, like so many worlds, its story is one of profound loss. As we look to the future, the search for Mars's secrets continues. With the advent of new technology, we stand on the brink of a new era of exploration. Human missions to Mars will allow us to dig deeper into the planet's past, literally. Astronauts will be able to drill into the Martian surface, gathering samples of rock and ice that may hold the answers we've been seeking for generations. By studying these ancient materials, we can learn more about Mars's watery past and the conditions that might have allowed life to thrive or not. With every new mission, we inch closer to answering the question that has fascinated scientists for centuries. Did life ever exist on Mars? As we search for the remnants of its oceans, we are also searching for the answer to a question that defines us as a species. Are we alone in the universe? Mars's ancient oceans are not just a relic of the past. They are a reminder of what might have been, a glimpse into a world that could have supported life, but which is now frozen in time. Mars's legacy is not just one of water and atmosphere lost, but of possibility. As we gaze up at the red planet, we are reminded that the history of our solar system is a story of transformation, a story of how life and death, creation and destruction are written into the very fabric of the planets. Mars, with its oceans now gone, remains a testament to the forces of nature and a symbol of our ongoing quest to understand the universe and our place within it. In exploring Mars's past, we do more than just learn about a distant planet. We learn about the fragility of life, the resilience of worlds, and the mysteries that still beckon us to reach beyond the stars. The red planet's oceans may be gone, but their legacy remains. A legacy of questions that will continue to inspire our search for answers, not just on Mars, but on the countless other worlds out there, waiting to be discovered.